So, welcome to our first PRISM seminar of the semester. Super exciting lineup for the semester, and so I'm glad that everyone took the time to be here with us today. Um, Dr. Christopher Barrie is an assistant professor of sociology at New York University. He's a political sociologist of conflict communication and political attitudes. Methodologically, he specializes in natural language processing techniques, language models, and the repurposing of digital trace data for social science research. He is particularly interested in advancing the use of social media, news, and communications data to study populations that have traditionally been hard to reach in the empirical social sciences. He's also interested in the use of new computational techniques for studying the relationship between online information consumption and political attitudes. While at the University of Edinburgh, he founded the Social Data Science Hub. I'll also ask that stay muted. If you have clarifying questions, feel free to put them in the chat, but we'll save general questions until the end. So, Chris, thank you so much for being with us.
Thank you. Let me just share my slides and go full screen. Just shout if there's any issue. Thank you so much, everyone, for being here. It's a great crowd to be able to speak to. This is a relatively new paper that you'll find the full version of, or the current version of, on archive. One thing that I'm not sure if Clint said is I'm completely happy with you interrupting me for any clarifying questions. If you said that, Clint, I apologize. I wasn't listening clearly. So I'll keep the chat up, or at least I'll monitor it. And Clint, you can shout if I'm neglecting to monitor it appropriately. This is a paper that's written with Eli Paleologo as well as Peter Turnberg from the University of Amsterdam. And I think it's a lot more important than the perhaps dry title of the paper might suggest, because I think it gets at something quite fundamental about how we're using new computational methods, particularly large language models, of which I'm sure everyone is at least everyone in the room has at least some passing familiarity with, because language models are now being used for everything. And by the way, sort of one sidebar here, when I'm talking about language models, I'm really thinking about things like ChatGPT, like Gemini, like Mistral, like, you know, these kind of well-known, like Llama, there's an open source version, these well-known language models that are being used in a variety of settings to do a variety of different things, which I'm going to provide you with some sort of overview of right now. The most obvious way in which language models are being used is to do something which we are classically interested in within the empirical social sciences and further afield, which is to annotate data in some way or another, to say whether something is Republican or Democrat, left-wing or right-wing, populist or not populist, right? And previously, we might have used some kind of supervised machine learning approach whereby we have a training set of data labeled with the correct answers, and we might refer to that as our gold standard. We might train on that training set, and then we look at how accurate our trained model is, that be that BERT or some other pre-trained transformer model, in order to annotate the data. Now, what we're doing, or what we're seeing increasingly, is the use of language models like ChatGPT and various others, GPT-4, GPT 3.5, whatever it might be, to annotate data in some way or another. And in order to do that, we don't necessarily need a training set. We can just prompt the model, right? We can ask it to do what we want it to do, to label as something as left wing or label it as right wing. And people have done more than just annotating data as well. They've also begun to generate so-called synthetic data. That is to say that if we have some kind of reference set of data, and a well-known example now in the political sciences, in political science is the use of something like the American National Election Survey to inform a model about the profiles of voters within a particular country, in this case the United States, and use those profiles in order to generate synthetic data, that is kind of made up profiles of other people. And we ask the language model, how would this person have voted had this person actually existed, right? Based on these kind of demographic characteristics. Now, the idea behind this is that if we can generate synthetic data on the basis of some kind of reference set, this really expands the possibilities of what we can do in the social sciences, because we no longer have to rely on these kind of laborious modes of collecting data by asking actual human beings about their opinions on something, about their voting intentions, whatever it might be. We can use made up data, right? As long as that made up data is reliable in some sense. Once again, the important thing to stress is the way we're generating that data, or the way it's been done to date, is again simply by asking a large language model to generate some output of interest, like how did this person vote or not, based on some kind of prompt, i.e. a list of this made up individual's demographic characteristics. People have gone even further than that as well. Not only are we using language models to generate synthetic samples of data, we're using them in a kind of agent-based modeling sense, uh, uh, in which the environment is actually kind of dynamic, right? On the basis of some input, what the output be, given this kind of starting set of information that I've given the language model. And people have used that, as I'll show you in just a second, to do things like simulating social media environments to see how the algorithmic architecture underlying a given environment might impact the toxicity or otherwise of interactions on that platform. And then finally, people have even started to run whole experiments on some kind of language model platform. That is to say, we can take classic experiments of old, like prisoner's dilemma type scenarios. I think somebody has even replicated the Milgram experiments, or tried to, right, using a language model. In other words, we can completely shunt humans aside and run everything that we would be classically interested in within the social sciences within the environment of a language model. Once again, the important thing to stress is all of this just relies on some set of prompts. However complex and lengthy those prompts might be, they are prompts nonetheless. We're not, in other words, relying in most cases on any kind of additional fine-tuning or pre-training of an existing language model. And these approaches, this is taken from Dimensions AI, which I discovered actually just in the past few days. This is an example of just how much language model use has taken off within the social sciences in the last 2 years. These are just sociology and political science publications, to the two disciplines that are close to my heart. So from pretty much zero papers in 2022 mentioning the words large language model, we have around 200 in 2023, and approaching 500 this year across a sample of sociology and political science journals. And as I said just a couple of slides ago, these have been turned to various ends, whether that be the simple annotation of data to determine whether or not a language model outperforms or matches much more expensive, but nonetheless, relatively cheap crowd workers to annotate data, whether we use them, as Lisa Argyle and colleagues have done recently, to generate synthetic samples of politically relevant data, whether we use them, as my co-author in this paper, Petter, has done, to simulate social media environments using language models as an agent-based type model, or whether indeed we're using them to replace the human component of social science experiments entirely, as in this paper by Barrie and colleagues. Okay, so to go back a few slides, what are we using language models for in social science? Well, as we can see, a variety of purposes. What I want to focus on really today is on these two. The use of language models to annotate data, and the use of language models to generate synthetic data. The reason I want to focus on these is because they're most obviously relevant to the package that we've written in order to aid us in the use of language models in the applied social sciences. Also because they are principally focused on the generation of a data set, right? Whereas ABMs and experiments are a lot more involved and a lot more interactive. That's not to say that we couldn't do the same thing in as we're proposing in this paper with these other settings. It's just to say that we haven't done that yet. Okay, so what is the standard practice for annotating data within the social sciences, at least within the social sciences that are now using large language models? Well, for those of you who haven't got any experience with language models, what I'm going to do now is run through what I see to be, I think what is commonly accepted to be, a basic pipeline for annotating some data set with the aid of a language model. So let's take a few examples. We might want to take a bunch of tweets and label them as authored by a Republican or authored by a Democrat. Right? There's better ways to do that, obviously, than using a language model, but stay with me. Let's say we want to take a bunch of tweets and we also want to label whether or not they're populist or not populist, based on some kind of definition of populism that we have to hand, or maybe a simpler task, a more classic task, whether we want to label the sentiment that a piece of text contains as positive or negative, right? Classic type of sentiment analysis. Well, the revolution in the last couple of years with so-called zero-shot learning, generalized pre-trained transformers, they have kind of various names under which these different types of models cluster. The revolution here is that instead of having to train some training set and label it ourselves, all we need is a prompt. That is to say that we can just speak to the model, right? We can say to it, I want you to take these tweets, and these tweets are from 2022, and I want you to tell me whether or not the author of each individual tweet is a Republican or a Democrat based on what you see, the information contained within that tweet. I want you to label it based on my definition of populism, whether or not that piece of text is populist or not. We might take those annotations from some basic kind of coding setup that I have. This is from another project of my own, where we're classifying tweets from individual UK MPs. And what I'm asking the model to do is to label it label it on a left-right scale from very left to very right. So you'll see here, I'm not sure if you can see my cursor, but you'll see here that I define within the context of the code what it is that I want the model to label. I say that I want it to label as from very left to very right. I say that I want you to do that on the basis of text content, and I give it some background here at the top about the domain from which these tweets derive. I then just feed that to the model and I ask it to annotate it based on that information alone. And that's what we're talking about when we're talking about a prompt. This natural language input up here at the top, in the top half of the screen, we're effectively just telling the model what it is that we want it to do in the same way as we might speak to another human being in everyday life, or indeed to a research assistant that we commonly use when trying to generate and prepare data sets. We then might take the results and we might analyze them in some interesting way. I didn't write, this is made up data, by the way, that I didn't make up myself, but asked ChatGPT to write for me. But anyway, we see on this plot, right, there's some kind of generalized decline in sentiment in whatever this made up data is. Then in order to document what it is we've done, we might also print in the appendix of our article what our prompts were that we used within the annotation pipeline that we have for the project we're working on. And then we might also document that code. That would be a good thing to do as well, right? We would document it on GitHub or GitLab, or Bitbucket, whatever it is that you like to use, so that people can not only see the prompts that you used, but the programming setup on which that relies, as well as the model, etc., that you are using, and so on and so forth. Now, this is pretty much what everyone is doing right now. It's probably the most comprehensive way we have of documenting what it is that we're doing in some kind of pipeline that relies on a language model for annotation. But what I want to communicate to you today, and what I want to argue, is that there are several things wrong with this kind of approach. And it's an approach that we're seeing very commonly now, at least within my field of the social and political sciences. Firstly, the prompt that we use, as much as it might be, it might perform very well for a given task, for a given prompt, might nonetheless be really, really fragile, right? So let's say I got lucky and I gave GPT-4 some kind of definition of populism. I gave it some tweets to which the model was kind of particularly amenable, and I asked it to classify whether or not those tweets were populist or not populist. And it gave me an accuracy of like 0.95 or something. And I think, great, right? We can run with this, and we would know that accurately through some kind of, post hoc inspection of the data. Okay, but what if I changed a few words to my definition of populism, and suddenly my accuracy goes down massively? Okay, this is where some kind of test diagnostic, I think, is really helpful and indeed necessary if we're using some kind of zero-shot setup to annotate or to produce our data. The second reason this is important, or the second reason there are problems with current approaches, is that, and this is not my term, but one I borrowed from various others, is that the author of whatever particular study, and this is particularly important, by the way, in an experimental setting, if the language model is delivering the treatment, the author might have prompt hacked, a kind of variant, if you like, on p hacking, with which I'm sure we're all familiar within statistical sciences. That is to say, they might have tried out a whole bunch of prompts, and then they might have chosen that one prompt that gave them the result that they wanted to see, right? In some settings, that's okay, because that prompt might have been really well defined and defined the problem really well, and that's where you got good results. In other settings, they might have just iterated through a whole bunch of different prompts and chosen the one that gave them the correct answer. And so this is where some kind of robustness requirement, I think, is really important for us within an applied setting in order to mitigate the possibility that researchers will do this kind of thing. In other words, if there's some kind of accepted standard for what we do when annotating or generating data in a zero-shot setting. And in some senses, this is kind of what we've already been doing, right, in social science. And I think there are really interesting parallels between what we're doing in a zero-shot language model setting and what we've traditionally done with human coders and so-called inter-rater or intercoder reliability. And this is where our approach comes in. What we argue in the paper is that intracoder reliability, that is to say, if I've got some data and I want to ask some research assistants to annotate it, 1-0 populist or not, I might ask the same individual coder, right, same individual research assistant, to annotate the same data multiple times. You wouldn't tell them that that's what they're doing, right? But you might repeat a bunch of rows and see if their annotations are consistent throughout the annotation process. And that's what we refer to as intra-coder reliability. That is to say, does the same coder annotate the same data in the same way when presented with that data again? And this gives us some kind of measure of internal consistency when asking a human being to annotate some data. And what we argue in this paper is that this is not unlike asking the same language model to do the same thing over and over again to see how consistent that language model is. Now, we also refer, probably more commonly, to intercoder or inter-rater reliability. That is to say, we often ask a bunch of RAs, 5, 6, 7 RAs, to annotate some data, and then we see how much in agreement they are for each individual row, for each individual piece of information that we're asking them to code. And this is sort of like, it's not exactly the same for reasons that I'm sure are presenting themselves to you. It's sort of the same as asking the same language model, maybe more precisely different language models, but stay with me, the same language model to do a similar job again, right? That is to say, we ask GPT-4 to annotate whether or not something is populist or not, and we shift the wording slightly of how we're defining populism on each iteration. And what we can then tell is just how fragile the or sensitive the model is to slight perturbations in the way in which we're defining the problem in front of it, right? And this is really important if we care about the overall reproducibility of what it is that we're doing within in some kind of applied setting. Okay, so here's how we're sort of thinking about this. And why reliability is important. So if we focus our attention on the column, on the highlighted column in this slide, we care about intercoder reliability for several reasons. Reasons that do not show definitively that we are successful for this given aspect, but do suggest nonetheless, right, that a coder is producing data on which we can rely. How so? Well, if intercoder reliability is really high, this does indicate that the coding decisions being made by an individual human being are not overly reliant on some subjective judgment. Right? What it also suggests is that the construct that we're trying to target, let's say populism, again, is a valid one, is one that has some kind of definable properties out there in the world which we are accurately targeting. And high reliability means also that if we were to try to repeat the same procedure, maybe with different research assistants in 3 years' time, that we would get something approaching the same answer, right? In other words, it has important implications for replicability or reproducibility. Now, we think there are important parallels here with how what we refer to as prompt stability is working. Now, if the prompt that we're using to define or to annotate some piece of data is particularly stable, that is to say, produces consistent results, that is some indication, though not definitive in any way, that sort of baked in biases in the model are not significantly affecting the classifications or the annotations that we're getting. High prompt stability also suggests that the construct that we're trying to target is valid. Again, it doesn't definitively show that, but it suggests that. And finally, high stability, and I think perhaps most importantly for what we're doing in this paper, means that language models can reproduce the same classifications were we to do it 6 months, a year down the line. Now, we also think there are obvious parallels for why things might go wrong. So why might intercoder reliability be particularly low? Well, it might be low if actually the way in which we've trained or instructed our research assistants is really quite ambiguous. Like they don't really know the nature of the problem in front of them. It also might go wrong if actually the data is just not up to the task. If the data is really messy or inappropriate, right? This can lead to kind of weird classifications or differences of understanding among our research assistants, among our human coders. Thirdly, the construct that we're trying to target may actually lack definable properties. So some people think that populism is not particularly definable, right? That it has variant meanings, and actually it's kind of a bump construct because it means different things to different people at different times, right? So this may indicate that actually the construct we're targeting just doesn't have a stable definition. And then finally, things might go wrong if the coders are just not up to snuff, right? They don't really know what they're doing. They don't have the requisite skills to annotate the data in an appropriate way. Let's say they don't know how to use Excel or something like that, right? Like coder skill is the issue here, or they don't know how to sort of interpret the text in the appropriate way. Well, again, there are obvious parallels to language models and to what we refer to in the paper as prompt stability. If our prompt is ambiguous, similar to our instructions to an RA, then this can lead to really inconsistent outputs. Similarly, if the data is complex, messy, inappropriate, the language model is unlikely to deal with that as well. And the result of that likely is inconsistent annotations. Thirdly, if the construct lacks some kind of stable definition, again, the language model is going to struggle to annotate it with any kind of consistency. And finally, there is variability in model capability. We all know this because of all the leaderboards that we see of which language model has the most capacity for sort of a range of tasks, and some language models are simply more powerful, more capable than others. So what I'm trying to communicate to you in these last two somewhat cluttered, I apologize, slides is that there are obvious and I think important parallels to how we've gone about the annotation of data by asking human beings. There are important parallels between that and how we're going about this process using language models. But I argue that there are important extensions to how we use language models. And we argue that there are important lessons we can learn from how we've approached questions of reliability with human coders that we can extend to a language model setting. Okay, so what are the current approaches to this kind of problem? That is to say, dealing with the inconsistency of language models. Well, they've been put to different ends. The first approach to this kind of problem is to repeat different versions of some original prompt. And the purpose of that is often to fine-tune models, in other words, to increase model performance, and also to gauge the uncertainty of models with a view, again, to making them more powerful. In other words, the output or the end goal is somewhat different from what we're doing in this paper, which is to provide some kind of diagnostic. Here, they just want to up the accuracy of their models, right? They're interested in accuracy. In other words, we're interested in the variance of outputs. Another approach is to elaborate kind of new approaches to how we construct prompts. So some in this room may have heard of so-called chain of thought prompting, various others that I could waste time mentioning, not to say that they're unuseful, but again, the purpose of this is to boost accuracy, right? The ultimate goal is to go from 0.86 to 0.88 or 0.89 right, at the end of the day. And then finally, some people have engaged in so-called prompt perturbation or substitutions. And there, the obvious example is a recent paper that looked at basic changes in the punctuation within prompt designs to see how that affected the model performance and to gauge overall stability. But what we do lack at the moment is any kind of dedicated routine or software package to achieve this kind of thing. And that's where we come in effectively with this paper. The Python package is still in development, but you can download the development package here. As my host will know, I'm a recent father, and this is co-authored with my wife. And so the development of this package has somewhat taken a back seat in the last 6 or 7 weeks, but we're going to get onto it soon, we promise you. Anyway, this kind of test development version is there for you to play around with, and I link to that at the end of this talk, and I'd be very keen to hear. Thank you very much, everyone in the chat, for you to play around with. Anyway, I lost my train of thought. Okay. So what is it that we're doing within this software package and in our paper that, as I say again, you'll find on arXiv? Okay, firstly, obviously, we take some data for annotation. In the actual paper, we take 6 different data sets and we specify 12 different outcomes. And I'll describe some of those in just a moment. But for the purposes of illustration, let's imagine a data set which is some tweets, and we want to label whether or not an individual tweet is populist or not. Okay, so within the so-called intra-prompt stability approach that I'll go on to show you some scratch code for just a moment, what we do is we effectively take the same data, the same prompt, label these tweets, whether it's populist or not, and we do that n times. Let's say, I think we do 20 or 30 times in the paper. What we then do, and this is the inter-prompt approach, is we annotate the same data, but we do it with different prompts, i.e. variants of an original prompt. And we do this j times, let's say again, 20 times, at k different temperatures. A temperature setting, for those of you who don't know, effectively controls the so-called creativity of a model. In essence, under the hood, what it's doing is like widening this kind of distribution over which the model can select, the next word in a sequence. And what this does is to make the models less constrained, right? And so if we're using a different temperature and we're trying to paraphrase an original prompt, if the temperature setting is higher, let's say approaching 5, and they start from 0 and go to in essence infinity, but let's say we go up to 5, then the likelihood is that our paraphrased prompt is further away in semantic vector space, let's say, i.e. the original meaning is further away from the original prompt if the temperature is higher. The idea here, right, is that we want to generate some paraphrases of the original prompt that that gradually decrease in kind of semantic proximity to the original one. Because we want to test how fragile our outputs are to some subtle, a slight change in the temperature setting, or to some relatively large change in the temperature setting. And I'll show you in just a moment what that looks like. How am I doing for time? Okay. Then effectively what we do is we simply calculate a very commonly used measure of intercoder reliability, which is Krippendorff's alpha, and we refer to this as our prompt stability score. We can then bootstrap some standard errors if you want to. Okay, in the interest of time, I think I'm actually going to skip through the scratch code. It may be illustrative if you want to go back to the slides. For whatever reason, I've written it in R. The original package is in Python, but it's scratch code anyway. Like, if you prefer R, you're in luck. If you prefer Python, then you can go to the actual code repo. I'm going to skip through this. We can return to it if you really want to get into the weeds of how this package is working. What we do to generate the prompt variants is we use Pegasus, which allows us to generate relatively computationally inexpensively some variants, some paraphrasings of our original prompts. We also allow users to specify their own prompts. That is also vulnerable to kind of hacking, but we do it nonetheless. Though we do recommend that if you do that, you need to kind of justify where you've done it and how you've chosen the prompts and so on. Okay. To annotate the data, we use in this paper GPT 3.5, LMM, other LMs are available. We do want to extend it, across various different language model domains as well. And as I say, we call this approach in its entirety prompt stability scoring, and the score that we end up with, the prompt stability score, PSS. Okay. Here's the data that we use. Again, a very busy and cluttered slide. So I'm going to focus your attention on this top right corner. And for the purposes of illustration, I'm going to get you to focus on, or I'm going to emphasize these two data sets. The first is a set of tweets by US senators. The second, a set of news articles in the New York Times. Both of these have been used in published research within the social sciences. And what we do is we vary some relevant dimension, or what we see to be as likely to be a relevant dimension within this data. Okay, so it's relatively straightforward to classify whether or not a tweet is by a Republican or a Democrat based on the information in that tweet. It's harder to classify whether or not it's populist. In other words, we're varying the complexity of the construct we're targeting. In the second, we're using some news articles, and we use two versions of this as well. The first uses the entirety of each news article, and what we're doing is categorizing whether or not the article is positive or negative about the economy, I believe. Now, if you have a very long news article, that might contain a range of different sentiments, right? If you have a short snippet of a news article, you're more likely to be able to say, okay, the prevailing sentiment within these few sentences is positive, right? So the short version of this is the more suitable data, and we expect more consistent annotations as a result. Similarly here, we're using data, if you direct your attention to the very bottom row, from a paper I mentioned earlier on, which is generating synthetic profiles of voters from ANES data. Now, the short version of this is again the difficult one. Is in this case the more difficult one, because we're removing particularly salient demographic information about that synthetic profile, which I think is whether or not you voted Democrat in the previous election, right? Which basically means the language model is always going to say you're going to vote Democrat again, because that's basically what people always do. If you take away that information, we expect our annotations to become less consistent. Why? Because the outcome is a lot more complex, a lot more difficult to predict. And I won't go over the BS survey responses, but I'm happy to talk about that. But again, we're talking there about varying the data complexity or suitability. Okay, here's the results for the intra-prompt approach. Now, what you can see is that up here, with the long synthetic version, right? We have very, very consistent annotations. And this, to remind you, are those profiles where the language model is told how this individual voted in the last election. And I think there's also some information about whether they consider themselves a Democrat or Republican, right? Like these two bits of information, with that, you're pretty likely to be able to say how an individual voted. In the short version, though, down in the very bottom right corner, we see a lot less stability. Now, overall, the PSS is around 0.8, but that's obviously a lot less than the 0.98 the longer form synthetic information received. And these are ordered, by the way, in order of overall stability. What we see, generally speaking, is that after kind of 20 runs, everything kind of stabilizes at a certain point that always exceeds 0.8. But to remind you, this is using the original prompts or something approaching the original prompts that we used in the original published research for these data sets. So some takeaways from this, from the intra-prompt approach. When the construct is unclear, stability tends to be lower. Where the data is unsuitable, stability tends to be lower. But where the construct is really clearly delimited, let's say in the top left corner, this is asking the language model to annotate what a survey respondent says to be the most important issue within some survey data, and that might be the environment or the economy, whatever it might be. Where that construct is very clear, stability tends to be pretty high. Okay, but here's where it gets interesting, I think. And this is when we vary the phrasing of the individual prompt. And I'm going to direct your attention to again, the bottom right corner of this plot here. What we can see, again, taking the example of the synthetic data from the paper by Lisa Argyle and colleagues, is that even at quite low temperatures, that is to say, when the paraphrasing of the original prompt differs only slightly from the original, we see overall PSS, or overall prompt stability, to really take a nosedive. The same is true of the longer form news articles. The same is true of the most important issue version when we're asking them to we're asking the language model to code a wider range of most important issues when there's some overlap. So when the paraphrasing, in other words, even differs only very slightly from the original prompt, we see that the stability of these models really decreases quite drastically. So overall, we see that across all of these different data sets and all of these different problems, stability does decrease as temperature increases. That's good for our intuitions, right? As the semantic meaning of a prompt gets further away from the original, we expect the model to become less consistent. What is most worrying, I think, and most important for our contention that the use of zero-shot language model routines requires some kind of diagnostic is that even at very low temperatures, the PSS seems to be decreasing quite markedly. Okay, so to conclude, just a few recommendations. As a lot of people have already been doing, I think we should all be providing the prompts within our replication materials, but I also think we should be testing prompt variants and showing the downstream consequences of using different variants of some original prompt, just to illustrate to the reader, to the reviewer, whoever it might be, how fragile a given pipeline might be, and to avoid or to mitigate, as I said at the top of this presentation, the likelihood that any given researcher is going to hack their way toward some result which they wanted to find. We think you should use our package to do this. We promise that it will be in a readier state in coming weeks and months. You'll find the development version at this link, and I will share the link to these slides in the chat in just a moment. I also tweeted them if you find me on Twitter. We do also recommend that for intra-prompt stability, it kind of makes sense to use a 0.8 threshold, which is kind of rule of thumb for the use of human coders anyway. Rules of thumb are helpful in some senses and not in others, but as some kind of measure of whether or not something is stable or not after, let's say, 20 iterations, 0.8 threshold probably sounds reasonable. If you go below that, then I think it requires some kind of ex post justification or explanation of why your model doesn't seem to be producing consistent outputs. Then for the interprompt approach, when our PSS dips below 0.8, just as a useful rule of thumb, particularly at low temperatures, researchers should investigate why that might be. Now, there might be good reason for that. The prompt might be missing a really crucial word for a given paraphrasing. But if actually the prompt describes the same problem in very similar ways, and yet we're seeing a rapid decrease in the consistency of our outputs, I think that requires some transparency on the part of the authors of any given study to show why and when that might happen. There are some further steps that I can go through, but I'd actually rather hear your impressions in the audience, and so I will conclude there, and thank you very much for listening. Thank you. Thanks, everyone.
Awesome. Thank you so much, Chris. At this point, we do have time for questions. So if you want to unmute and ask questions or leave them in the chat, one of us can also read them for you.
quick question. Thanks,
Yeah,
Chris, so
please.
much for this talk. This is great. Um, I have my sense is that a lot of this, there's pretty big advantages to sort of following this approach, in part because the prompts themselves are a way of being transparent with what your criteria are, and in a lot of ways is an easier way to access these models. But I'm curious if you have any sense of how the sort of like disadvantages of following these approaches that you're in a lot of ways you're sort of trying to compensate for the like squishiness or the variability of the models themselves in this sort of form as they're used. A different way of sort of approaching the same problem would be to just use the embeddings themselves and just fit a model on top of those embeddings directly based on some labeled data set. And in that sort of paradigm, they're just back to a pretty traditional modeling approach where you maybe say you have some training set, you train a classical model, you reserve some like validation set that then you report the performance on. And that feels like it circumvents a lot of this like squishiness or variability issues that you highlight here. And there might be disadvantages to that. So I'm curious if you've like looked into that or if you have any thoughts about that alternate approach to annotation. Thanks.
Yeah, that's a really great point. It's one that I'm actually thinking about in a separate paper with Arthur Sperling and Lexi Palmer about broader questions of reproducibility in language model settings. You mentioned, why not just fine tune a model on top of the available embeddings? The obvious answer to that is, well, for a lot of closed source models, the weights aren't available to us for use, right? We can fine tune them, but we still don't really know, what it was trained on, what's going on behind the scenes. So there's still, excuse me, a kind of interpretability problem there. The second reason why, I'm not saying you shouldn't do this, but why I guess people wouldn't do that is because even fine tuning some kind of pre-traditional model will likely give you worse accuracy than using some massive language model. And that's why people are preferring these now. So I think part of the motivation for what we're doing here is the recognition that people are going to use language models, and they're going to use them because there are performance advantages to it, but also because there are, frankly, fewer startup costs to using something like ChatGPT to label your data than fine tuning some transformer model. That is to say, we're trying to work with what people seem to be doing, what we observe people to be doing in applied settings right now, and trying to kind of work around that. I nonetheless can take your point that there are alternative approaches. We can also use open source models, and I would be a big advocate for that. But again, startup costs are higher. As a kind of meta response to your question, I would say that I also feel a kind of unease for trying to kind of compensate for the inadequacies of a lot of these approaches. And I think we're also going through a period of time on which we're going to look back and think that some of the things we ended up doing with language models were really weird and really stupid, and that's often the case when something really takes off. But I guess this is some kind of small contribution that we're doing to try to sort of mitigate against some of the dumber dimensions of using these extraordinarily intelligent models. But yeah, thanks. It's a great question. I think we should build it into the paper, or our sense of it into the paper a bit more. Thank you.
Great, thank you.
We have a question in the chat from Mushi. She asked, why does the performance usually stabilize after 20 iterations? Is this number 20 also a rule of thumb or some kind of magic number? Or is there a memory or self-learn process that's going on?
Yeah, that's a very good question. I don't. We ran all of these tests before OpenAI started talking about their models having any kind of between run memory. we're also using a model that never claimed to have that kind of memory. Again, this is another problem of like using these commercial models. Like, who knows what's going on? Uh, I think yeah, we suggest it in the paper as a kind of rule of thumb. It will obviously depend on the number of uh, um, the amount of data you're actually annotating at each run. The reason the standard errors are kind of reducing is just we have more data over which we're kind of bootstrapping those errors. So that's maybe kind of misleading. What it is important to say, and what I think we should also include in the paper is when the prompt is bad to begin with, and we run that intra-prompt stability routine, we see it stabilize at around like zero 0.4 as a PSS score, as a Krippendorff's alpha. So, you know, that is to say it stabilizes, but it stabilizes at something quite bad. It's not to say that after 20 runs, everything always stabilizes at 0 0.8. That only happens when the prompt is like a reasonable one to begin with. Sorry, I was trying to pick on people myself. Clint, I defer to you.
Go ahead, Amanda.
I'll go ahead and ask. Hi, thank you. This is super helpful. I have a question, and it's sort of like maybe a broader ontological question, so forgive me if this is like not artfully asked, but the relationship between, or the posited relationship between construct validity and prompt stability, like that makes sense to me within the schema of the large language model and like the universe of text that it has access to. But that relationship seems to me a little bit more strange or tenuous when we step outside of the model itself or the text that it has access to or everything that it was trained on. So are there, I guess my question is, are there any approaches to sort of quantifying that like ontological dissonance or that ontological sort of error rate? Something.
Yeah.
I don't know if I'm like completely making sense, but I'm just like.
No, that's a really interesting question. To which I fear that I don't have a good response. But what it does get at, I think, is again something we're sort of pointing towards in separate work with Arthur Sperling and Lexi Palmer, and that is to do with how we theorize what we understand by kind of reproducibility and reliability when we're using a language model. Because as you say, a language model can be extraordinarily impressive, annotating some tweets that it's probably already seen in its training data set, right? But presented with some kind of new scenario, new setting, one wonders just how well it's going to perform. Now, I suppose you could still say that there are analogies there to human beings. You know, if I pluck a research assistant who's been stranded on a desert island for the last 10 years, they're probably going to be less good at telling me what populism is, right? Than, you know, they're probably not going to care either. But you see what I'm saying, right? There are still some analogies there. I'm interested to hear from you what other kind of scenarios, not to say that, you know, text is the only thing that matters, but, you know, at a higher level, what other kind of scenarios are you thinking about when playing around with that analogy in your mind?
For sure. I mean, thinking about, and I want to make this brief so that Brian gets to ask his question, but just thinking about like the way in which results like this can get away from us, and that non-technical audiences can absorb findings like this. Like the idea of populism is a concept that is not only like, it's a relational concept because it exists in a place and time, and it's like historically bound. But when we start assigning things like scores to large databases of annotated text, we can start to interpret these things as a bit more real, intrinsic, or like ontologically true than they potentially are. And that's, I guess, my concern. And like the attempt to incorporate that into the analysis or bound that into the way that we approach uncertainty generally, I think is like a thing we should do, and I don't know how to do it.
I think that's really, really astute. it, it kind of gets at another problem that is really difficult to grapple with on some kind of theoretical level, that again has to do with reproducibility, because we might say, well, in 10 years' time, I want my populism labels to be the same as they were when I labeled them 10 years ago. But like maybe populism changes in 10 years' time, right? Maybe what we understand that to mean is slightly different. And then it gets at questions of temporal validity and what it means to reproduce something in a different setting at a different time. Yeah. You get into pretty murky waters pretty quickly. I think there are two sort of relevant domains here. One is sort of model interpretability that has relevance to what we're doing here, and the other is broader sort of ontological questions of what it means to annotate something correctly at a given time, and what like a gold standard even means. Which I guess we'll have to stay away from just because I'm not very good at answering them. But I accept that it's an extremely good point. Yeah. I think we still have time for Brian's question. Yeah.
Cool. Thanks so much. I really like the presentation. And you kind of structure your paper as kind of making an analogy to a well-established procedure, right? Which is like having an instructor and having a bunch of coder and using inter-coder reliability, right? So if I may just like, what is the best analogy to think about PROM, right? And if I can use another well-established procedure and think of PROM as hyperparameter that we can tune, right? There's million possibility of different mini value that we can tweak and, you know, kind of produce different prediction result. And if we think about PROM as hyperparameter, can we think about a procedure like cross-validation, right? Just run through a bunch of iteration of PROM and then kind of have some sample data and then maximize the in-sample accuracy. And then that will be our gold standard, something like that, right? So does that analogy work? How does that analogy work with your analogy of like intercoder reliability, and how might that be synergistic with one another, right? Because your diagnostic doesn't give us a clue of what should be the best PROM we can pick, right? Then we have to refer to some kind of manual tweaking. Maybe we have to run the PSS again and choose whatever PROM that is maximized by our kind of backblast procedures. So I just want to run that idea about you.
Yeah, I think that is a really nice analogy. What we've tried to do in the paper, it sounds like you've read, so thank you for reading it, is that there is a distinction to be made between broader, concerns about accuracy, which are of course important, and consistency. And the consistency comes in, I think, for two reasons, or for several reasons. The first is if we want to approach a problem, and we think about using a language model to do it, and then we ask that language model, n times, 20 times to annotate some data, and we see that the consistency is all over the place. This could be some, indication that using a language model is a bad idea, right? So it's going to save researchers some time. That's where inconsistency matters. The second reason has to do with basically, as I answered in the question before, how people are using these in applied settings, which is they are using zero-shot approaches a lot of the time, and a lot of the time, I think we should be concerned about just how replicable a given approach is. There is obviously an analogy with something like cross-validation, and if we were to do things really comprehensively, we would also be obviously fully validating whatever labels we're getting out of a language model. I fear that's not always happening. And what we're doing in this paper is some small step, I think, to mitigating some of those misuses of zero-shot approaches. But yeah, I think that's a very good point. One to think about. Thank you.
Awesome. Thank you all so much for coming. I want to thank Chris again for taking the time to talk to us. And real fast, I'd like to plug our next talk, which is October 9th. Yuki Gu from Columbia Statistics will be here in person, though there will be a hybrid option. So hopefully we can see you there. Thank you again, Chris.
Thanks so much, everyone. Great questions. Really enjoyed it. Bye.